I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we will briefly discuss about linear regression method. This is one of the classification method of supervised machine learning. Linear regression method, if you are taking, is a basic yet powerful algorithm in supervised machine learning that is used to predict a continuous numerical value based on one or more input variables, also called features or independent variable. We can call it as features or independent variable. It works by modeling the relationship between the inputs and output. Output, we are calling it as the target, that is the dependent variable. Input is the independent variable using a straight line. For example, it can be used to predict the house prices based on area and number of rooms or forecast sales based on advertising spent. There are two main types of linear regression. Simple linear regression means only one feature we are using it, which involves a single independent variable with two or and multiple linear regression which involves two or more independent variables. The simplicity and interpretability of linear regression makes it an ideal starting point for regression problem. Next, basic concepts of linear regression. So the foundation equation, this is the basic equation for the linear regression. Y is equal to b naught plus b1x plus epsilon, where y is the dependent variable, or otherwise we can call it as output or target. X is the independent variable or input features. B naught is the intercept and B1 is the coefficient, that is slope, and epsilon is the error term. This equation represents a straight line, and the goal of linear regression is to find the values of b naught, b1, etc. that minimizes the error between predicted and actual value. If suppose if I am giving the target as 10, if I am keeps on giving the input values as features, if my target value is matching with the whatever the input I am giving, so there's no error. Till we get a zero error, we keeps on iterating this algorithm. And what are all the assumptions made in the linear regressions? The first one is the linearity. For linear regression, to provide reliable result, several key assumptions must be met. First, linearity assumes a straight line relationship between the independent and dependent variables. Independence means that the observations or data points should not influence one another. And homoscedasticity constant, in this case, it refers to the condition where the residuals, that is errors, have constant variance across all levels of independent variables. Finally, normality assumes that the residuals follow a normal distribution, and violating these assumptions can lead to inaccurate models, incorrect predictions, and misleading statistical conclusion. Next. So this is the basic equation. And next one is the simpler. This is the simple linear regression. As I said, y is equal to b naught plus b1x if suppose there's no error present. It involves a single input and feature and model the relationship between the features and the target using the formula y is equal to b naught plus b1 x. The aim is to find the linear line of best fit that minimizes the difference between the actual and predicted value. This is often done using the cost function, that is mean square, that is mean squared error. It is given by MSE 1 by n summation I to 1 yi minus yi cap square. This is the actual value, and another one is the predicted value. The model uses the optimization techniques like gradient descent or normal equations to find the optimal values of the intercept and the slope that minimizes the MSE. MSE means mean square error, thereby achieving the best fit. So here we have to get a zero error. Then only we can call the model as the best fit. This is for a simple linear regression. If you are going for the multiple linear regression, the formula, instead of using this b0, b1x, here this is independent variable, this is the dependent variable, only one variable relates with the one output. Here multiple variable, why? The output relates with the multiple inputs, x1, x2, x3, these are all the coefficients. Multiple linear regression extends a simple linear regression by using two or more input variables, two or more, and predict the outputs. The formula is given by y is equal to b0 plus b1x plus b2x2 plus bn xn. In this case, b0 plus b1x only. Here b1x1 plus b2x2 plus bn xn. And each xi represents different features and bi represents the coefficients. That shows how strongly the features influences the target. The model essentially fits a multidimensional plane, that is hyperplane, through the data, and the coefficients help intercept the individual impact of each variable on the target. This type of regression is useful when multiple factors influence the output, such as predicting employee salaries based on education, experience, and location. Say, for example, the salary, many faculties, many members will be there, only one output as the y, independent variable. And how you are going to evaluate the metrics? So, evaluate the metrics for linear regression. First one is to access the accuracy and quality of linear regression model. Several metrics are commonly used. That is R square. Indicate how much of the variability in the output is explained by the inputs, with values closer to 1 representing a better fit. Next, adjusted R square refines by adjusting for number of features used. Mean absolute error, MAE, measures the average magnitude of errors without considering the directions. Next one is mean square error, MSE. This we have seen it previously. It penalizes the large error more heavily by squaring them. Last one is the root mean square error, is simply the square root of the mean square error, and provide error in the same unit as the target variable, making it easier to interpret. By making use of all those concepts, we'll solve the problem in the later classes. And even though it has got some advantages, it has got many advantages. It has got some limitations also. And although linear regression is widely used due to its simplicity, it has some limitations. It is sensitive to outliers, which can skew the model. It also assumes the linear relationship, so it may not perform well with nonlinear data. And multicollinearity, where independent variables are highly correlated with each other, that we can call it as the multicollinearity. Means independent variable, that is x1, x2, x3, are highly correlated with each other, can also reduce model performance and interpretability. And despite these drawbacks, linear regression has numerical practical applications. So it is used in real estate to estimate property values, in retail and marketing to forecast demand and sales, and in healthcare to predict outcomes based on medical records and trends. So this is the simple linear regression graph. This graph included in this case is a typical simple linear regression scenario. The blue points represent the observed data values for two variables, and the red line, this line, is the best fitting regression line derived using the least square method. This visual representation makes it easier to understand how the model attempts to find linear and that minimizes the overall distance error between the observed data points and the predicted values on the line. The graph also provides a quick assessment of how well the model fits the data. This is the data point, this is the regression line. Y is the dependent variable and X is the independent variable. So in this way, the linear regression model is used in the supervised learning. Hope everyone understood the concepts of linear regression. The remaining things we'll discuss in the next class. Thank you.